theoretical consideration of transportation problem. Suppose we have a transportation problem involving movement of item from M source or origin to N location, destination at minimum cost. Let Sij be the unit cost of transportation an item from source I to location J. Ai be the quantity of item available at source I and Bj be the quantity of demand. The theoretical consideration let us know that how can we split the items and the quantity available and the quantity of the cost easily so that we can what? We can minimum what the cost of transportation model. If you remember that transportation model is a what? The case of linear programming problem that this is what? That this with the word minimize of cost from the source to destination. Our source is also known as our origin. So our origin to destination or source to destination. And then again, we now represent our source as M. We now represent our destination as N. So this is how we have M and N. So at minimum cost, let Sij be the unit cost of transporting an item from source I to location J. The unit cost is termed as the decision variable of this minimum cost. We represent in transportation problem, we represent the decision variable as Sij. So we have Sij be the unit cost of transporting an item from source I to location J, and A subscript I be the quantity of item available at source I, and B subscript J the quantity of demand. So it means the supply, those that are supplying the item or what they want. So those that are requesting it, they are the demand, that they requesting what they want, and it must be a minimum cost. It must not be maximum. If it is maximum, it means what? It cannot be balanced. It is an unbalanced type. So they must have a conclusion between themselves that the source that what they are bringing to them, they must accept it, because what? That's why we have a minimum cost. Whenever we have the source, our source and our demand must be the same thing. They must be what? They must be equal. When the source and demand are equal, the cost of items are equal. It means what? The transportation model is a balanced type. So this is how we will formulate transportation problem. We have 1, 2, 3 to N, that is 4, 5, 6. This is our demand, this is our supply. They have 1 here. So it means our 1 is X11, S subscript 11, S subscript 12, S subscript 13, S subscript 14, 15, 16 to, it depends on the word, how the to another location. If it is 2, S21, S22, S23 till N. If it is 3, S31, S32, S33, S34. We have been given all these items. You just know, you just put it, be given these items available for you. You just know the supply and demand and formulate what? The transportation problem. So this is just a theoretical consideration that what you have to know. Then we're trying to do here, you can able to what? Formulate or program the what? Model. So our M, so it means that what? If it is 4, 5, if it is our cost of transporting item, that is our Sij. It depends. If you are given like this, it means you are stopping here. If it is continuing, it depends on how many the cost of transporting item you are giving. So if it is continue, it will now be S41, S42, S43. If it is on 5, S51, S52, S53, T to N. So if it is, so our demand is Bi, P2, P3, P4. We'll be giving supply separately, we'll be giving demand separately. The table of supply will be available, the table of demand will be available. Remember, our supply and demand, the cost, all the items of there, the total cost of item of supply, the total cost of what? Demand must be equal. So that the what? So that transportation model can be a balanced type. So that's why we have a minimum cost. So here we now have a subscription sign that So this subscription means what our I is what SIG, S11, S12, S13. So if it is other, if it is for A1, we have subscription of this. I is equal to 1, AIG, AI. It means our I is 1, our I can be 1, 2, going. So this is our programming model of this. If also if it is BI, we now have what? So summation of n to summation of I is equal to 1 to n, we have BI. It means to be B1, B2. So our I is what? Our I is what? 1. I is equal to 1, 2, till n. So that's why we have this. This is how this is a theoretical consideration of transportation model. So this enables us to be able to what? To program or minimize the cost of transportation. Then Sij must be greater than or equal to 0. It means our Sij must be greater than, this is a what? Non-negativity constraint. That is, our Sij must be greater than 0. This simply means that we must not have a negative, any negative for the what? For the cost of transportation. It must not be negative.